Assalamualaikum warahmatullahi wabarakatuh. My name is Khairi bin Radzi, Matric number 1810713. This is the video presentation for the metallography part experiment in Automotive Engineering Lab 1. So there are two experiments that have been done. The first one is the heat treatment and the hardenability test of steel and the effects of their mechanical properties. And the second one is the Jominy test. So for the first experiment, the objective is to determine the hardness and the impact properties of steel treated at different heat treatment processes. And the second objective is to find the effect of heat treatment on the mechanical properties for each steel. So in this experiment, we will prepare 5 specimens of steel. So 4 out of 5 specimens will be heated in a furnace at 600 degrees Celsius and being held for 2 hours, while the other one will be left untreated. And once the specimens have been heated, it will undergo different cooling processes or heat treatment. 2 of the specimens will be quenched into water and also oil. The other one will be left to be cooled inside the furnace, and the last one will be cooled at ambient temperature. So note that each specimen will undergo cooling process right after the specimens was taken out. Once the specimen have been cooled to room temperature, it will undergo the hardness Rockwell test and also the Chappie impact test. So since we don't have the actual result of the experiment, so the expected result will be based on my search or findings in the internet. For the hardness test, it is expected that the highest amount of hardness will be for the quenched steel. This is because the structure of the steel have been completely transformed into martensite. So we know that martensite will harden the steel. This is because the rapid cooling of the steel inside the water and oil will transform the structure into the martensite. So it is known that martensite will make the steel harder. And note that the steel that has been quenched in the water will be harder than the oil, because water is have better cooling rate than the oil. For the anneal or the steel that was left to be cooled inside the furnace, have the same mechanical properties as the normalized steel, which have been cooled at ambient temperature. So both of the steel have the same mechanical properties, which is soft and ductile, because the slow cooling rate only transform their structure to maybe some composition of ferrite and pearlite. But we note that normalized is stronger than annealed steel. This is because the cooling rate is quite faster than the annealed steel. So we know that there is composition of pearlite and a little bit martensite, so that the steel have a little bit properties of hardness inside the steel. And finally, the non-heat treated steel might be between annealed and normalized steel. The hardness value is between the annealed and the normalized steel, because from my finding, it is stated that basically the steel that have been provided from the manufacturer is same as the annealed steel, which is easy to machine and quite soft. So it is expected that the hardness value will likely to be same as a nail. Okay, for the choppy impact test, the way this test was done is by we are looking at the amount of the energy absorbed by each specimens, which is the energy will indicate the losses or the energy required to break the steel during the impact. Alright, from my finding, it is expected that the highest amount of energy absorbed or the toughest steel is annealed steel, because the it have the slowest cooling rate among the other heat treated steel, and from that the microstructure has transformed to pearlite. So we know that pearlite has high ductility and soft. So the ductility represent the toughness of the steel, and the lowest amount of energy absorbed or the weakest steel among the heat treated steel is the quench steel. So we know that the microstructure is martensite, and it is hard. It has the highest amount of hardness, but it's brittle. So the energy required to break the steel, it has the lowest amount. And for the normalized steel, it is expected that the value is between the quench steel and annealed steel, but it is tougher than the quench steel because it is tougher than quench steel but weaker than annealed because the composition of the microstructure is martensite and pearlite, so it is not fully pearlite, hence it has a quite brittle properties inside the steel. Okay, so for the choppy impact test, we can conclude that the ability of the steel to absorb impact depends on their microstructure. So this microstructure will be depends on the cooling rate of the specimens. Alright, so the steel can absorb higher impact if they are less brittle, which consists of fine pearlite structure. So like I said earlier, the annealed steel has fine pearlite structure because of the slow cooling rate. So we know that it is less brittle and ductile. Hence the toughness will be the highest among the other steel. Next experiment is the Jominy test. The objective of this experiment is to measure the hardenability of the steel bar under different cooling rate, and also we want to distinguish between the hardness and the hardenability of steel. For the experiment, we will be using a cylindrical shaped steel bar. So the specimens will be heated inside a furnace at 800 degrees Celsius for 45 minutes, and then once it has been heated, the specimens will be placed in a fixture inside a water basin. So inside the water basin there will be a fountain of water splash will be splashed onto one end of the heated specimens. It will be quenched for 20 minutes. Note that only one end of the steel bar will be splashed by the water, and once it has been cooled to room temperature, the specimens will be marked by 5 different points, depends, it can be 10. So from the specimen we are taking 5 different points from the quench end to the opposite end of the steel bar. Then the hardness Rockwell test will be done on the spot that have been marked on the specimens. From the previous experiment, we know that the hardness or hardenability of the steel is commonly related to the microstructure of the steel itself. And now we know that once the steel bar have been quenched by the water, the microstructure will be transformed into the martensite. But note that there are different between the cooling rate will be different on each spot that have been marked, because only one end of the specimens is quenched by the water. So the cooling rate will be progressively slower from the quench end to the opposite end of the steel bar. And it is so we know that only one end that have been quenched by water, so it has the highest cooling rate among the other point. So they expected that at this point the hardness level is the highest, because it has the rapid cooling rate other than the point that have been marked. This is because at this spot, or the quench end of the steel, the structure have been fully transformed to the martensite. Hence, it will have the highest level of hardness. So because of the cooling rate is progressively slower from the quench end towards the opposite end of the specimen, so we can expect that the hardness will be decreased progressively from the quench end towards the opposite end of the heated steel bar. Hardenability of steel is the ability of the material to be hardened in a large depth, or the ability of the steel to completely transform to martensite at a given depth below the surface once it has been cooled. Okay, let's say when a thick steel is quenched by the water, the inner core or the interior core of the steel will take much longer time to be cooled. So from the surface towards the center of the steel, there will be the variation of cooling rate. The martensite that was formed also will be different from the surface towards the inner core of the steel. Hence, it can be said that also will be leads to the variation of different hardness across the section of the steel component, because of the different percentage for the martensite that have been formed. For we know that from the hardness test, the hardness is decreased from the quench end of the rod towards the opposite end of the steel rod. So we can say that the hardenability of the metal also will be decreased progressively from the quench end towards the opposite end of the steel bar. Alright, from the expected result that have been discussed earlier, we can conclude that the higher the cooling rate of the treated material, the higher the hardness and the hardenability of the material. So for this case of the steel bar that has been quenched at one end of the steel bar, the hardenability, both the hardenability and the hardness of the tested steel bar will be decreased from the quench end of the bar towards the opposite end of the bar.